Hello and welcome to Algebra Unit 1, Concept 2, Lesson 6, our first Aspire to lesson. So you have gotten pretty far. So, again, you should be filling in your guided notes as we go. Today's objective, scholars will create real-world situations that can be modeled with a given equation and will create their own real-world situation and then solve the equation and make sense of the resulting solution in the real-world situation. So which situation matches? So we're looking for a situation that matches this equation 3.5x minus 2 equals 40. So situation A. I buy 2 sandwiches for $3.50 each and give the cashier $40. How much change do I get back? Situation B. A taxi costs $2 to get in the cab and then $3.50 per mile driven. If my total cost is $40, how many miles did I travel in the taxi? Situation C. I purchased some toys online that cost me $3.50 each. I have to pay $2 for shipping the items to me. If I spend $40, how many toys did I buy? And finally, D. I buy some books for $3.50 each and have a $2 off coupon. If I spent $40, how many books did I buy? Take a minute and see if you can figure out which equation matches. Okay, some things to notice here. All of these situations use a 2, a $3.50, and a 40. So all of them have that. So we need to look at what each of those represent. Okay, so like I said, for all of them, we have a 2, a $3.50, and a 40. So 3.5x, if we'll notice, let's erase that because I covered everything up. So the 3.5x, 3.5 is our rate of change. Okay, so 3.5 is our rate of change. So we need something that changes by 3.5 per something else. We also need to look at this minus 2. Minus 2 means after I figure out how much I did there, I need to take 2 away. And finally, the 40 must be an amount that we equaled. Okay. So, let's look back at these. I buy 2 sandwiches for $3.50 each, and I give the cashier $40. Well, that doesn't work because I'm not taking away 2. I'm buying 2. So, I can say that situation A must be wrong. Let's look at situation B. A taxi costs $2 to get in, and then $3.50 per mile. Well, I got my $3.50 per mile, so that definitely works there. But it costs $2 to get in. I'm not taking away $2. So that one's not right. Now let's look at situation C. I buy some toys online. They cost $3.50 each. So I've still got my $3.50 each. So that works with my rate of change. I have to pay $2 for shipping the items to me. Does that take away 2? No. That does not take away 2, so I can cross that one off my list as well. So now we're looking at D. D says, I buy some books for $3.50 each. Okay, so I've got my rate of change. I have a $2 off coupon. Okay, that definitely works. $2 off and take away 2. I spend $40. How many books did I buy? That means that my variable must tell me how many books did I buy. So that one works. So that's my correct answer, D. Do you see how I was able to get that from there? So let's go on to another one. So how can I write an equation or write a situation to match an equation, huh? So first we have to decide if you want to change the format. So equations can be written in different ways. I could have 15x plus 3 minus 2x plus 8 equals 14 minus 2x. Well, I may not like how that looks. So I may want to rewrite it. And we've talked about this. You know how to rewrite a situation in order to solve it. So maybe we don't like the format. Maybe we start going ahead and simplifying. So I have 13x plus 11 equals 14 minus 2x. We add 2x, so they can be 15x plus 11 equals 14. That might be a little bit easier to write a situation for. And that's fine. I like mine in y equals mx plus b. Remember, so when we use y equals mx plus b, we can see very clearly our rate of change. And we can see our starting point. It makes it easier for us to come up with something. Next, we have to decide what the variable represents. If we're given an equation, we have a variable, we have to decide what does the variable represent. So we are going to look at the coefficient, the number multiplying our rate of change for some ideas. What does that coefficient bring to mind? Do you think 350 is the price of something? Finally, we have to determine what any constants represent. So our constants are just numbers. So what's being added or subtracted? And what does the equation equal? What has the same value as it? So when we do that, we need to think about, am I adding 2? What does that mean? Am I subtracting 3.7? What can those represent in that context? So let's write a situation for 3.75x plus 8 equals 68. First, I need to decide if I want to change the format. It's already in y equals mx plus b. So, first thing we do is, what is my rate here? So, my rate is 3.75. And then I'm adding 8 for something. So, what does the variable represent? Well, how about if I make the variable represent the price of something? Think about something that you think would cost $3.75. Then, what would a plus 8 represent? And we need it to equal 68. So I might say that I spent $3.75 on books. Maybe the $8 is tax, processing, shipping, some sort of fee, because I'm adding it. And then my total spent was 68. So let's look at one more. This one, we need to decide if we want to change the format. Do I want to rewrite this? I can. I can rewrite this. I can subtract the 18x from both sides and end up with 7x plus 15 equals 36. Maybe I like that better. We need to determine what the variable represents. Remember, our variable here is our x, but it has a rate of 7. So something has a value of 7 in some way. And then Are we adding or subtracting? I'm adding 15. So at some point I need to add 15 to that value. If it's money, we add that. If it's number of inches, we add 15 inches. And then why do I want it to equal 36? Come up with your own situation for it.